Hello, Math 143. So today we are going to continue our conversation about money management. And today's topic is simple interest. So simple interest is exactly what it sounds like. It is the most basic type of interest that can be paid on any of your loans. It is also the most basic kind of interest that can be paid to you if you have money placed into a bank or um, lend money to someone that you know. So, interest is the extra money that we either pay to someone for allowing us to use their money or the extra money that is paid to us by a person that borrows. The other definition that we want to know is principal. Principal is the amount of money that we are borrowing or lending. So that's kind of our starting point for any of these calculations is we're going to need to know what the principal is in order to figure out our interest rate. So, a few more words. Annual percentage rate. The annual percentage rate is how we determine how much interest is going to be paid every year. Right? And it is a percentage rate. So it's some percentage of the amount that we are borrowing. Um, simple interest just means interest is calculated on the amount of money that is borrowed and only on the amount of money that is borrowed. So it's not calculated on anything else. So we're dealing with a situation where the length of time that we borrow the money, that length of time is also called a term or the term of the loan, is some fixed amount. And we will calculate the amount of interest that we'll pay based on the interest rate, the amount that we borrow, and the length of the loan or the term. When the loan time is up, that is called our due. That's when our loan is due. It's like our due dates, just like due dates for assignments. And origination date is what we call the day when the loan is actually issued, when the event actually happens. Now, when we get into some larger situations, as in mortgages, those kind of things take some time to actually get everything lined up just right. So the origination date might not be the same day that you actually started working on the mortgage and getting it set up. So sometimes those days can change a little bit. Let's make sure that I got everything on here that you will need to know. We're going to be using all of these words throughout this entire section and even into 6.4 and further down, especially in possibly your project, if you're doing the project in this section. So you'll be hearing these words over and over. When we are doing these calculations, we have to use variables because it's so unwieldy to constantly write interest, interest, interest. So we just use I for simple interest. So our first formula is our simple interest formula, and it is I equals the principal, or the amount that we borrow, times the annual percentage rate, which is represented by lowercase r, times the time of the loan. We're always going to use the decimal for our interest rate. We're always going to change it from the percentage that they show us into a proper decimal. The total amount of money that is owed for the loan is always going to be T equals the principal plus your interest. Okay. Sometimes you will hear it called the payoff amount. Sometimes just payoff, sometimes total. Right? The total amount or the payoff amount that we owe on our due date is principal plus interest. So let's go do an example or two. So our first example is asking us to calculate the simple interest to be paid on this loan and then calculate the loan payoff. So we're going to need two formulas. Simple interest formula is I equals principal times rate times time. The formula for the payoff, or the total amount that we owe, is T equals principal plus interest. So now we're going to fill in our values. Our interest is equal to P is the principal. So the principal borrowed here is $4,000 times our annual percentage rate, which is 5.5%. But again, we're going to write that as a proper decimal, so 0.055. And then that is times the time. And the number of time, or the number of years we are given here is 4. And I'm going to show you a different calculator today, because in some of our upcoming calculations, we're going to need something with a little bit more, I guess you could say, ability than the regular computer calculator. So this is the Desmos Scientific Calculator. It's free online. You are more than welcome to pull that up. So ours is 4,000 is borrowed times 0.055, our annual percentage rate, times 4 years. And our interest was $880. Now our payoff amount is our principal. And I'm going to go down, set these up vertically. So principal plus, or excuse me, our total equals our principal plus our interest. So P plus I, and that makes 4,000 plus 880. So my total is equal to $4,880 will be owed at the end of 4 years. Okay, we're going to do another example. Do this one a little bit faster. And it is asking us to calculate the simple interest Simple interest is I equals P times R times T. And then it is asking for the payoff amount. Payoff is T equals P plus I. And everything just disappeared. There we go. Wrong problem. Okay. So my principal is $3,500. My annual percentage rate is 2.5%, and as a decimal, that is 0 to 5. And my number of years, my T, is 10. So my interest is 3,500 times 0.025 times 10. So let's get our calculator back from Desmos Scientific here. And we have 3,500 times 0.025 times 10 years. Our interest is $875. Our total payoff is principal plus interest. So our principal is $3,500 and our interest is $875. When we add those two together, we have $4,375 is our total payoff. Okay, the next problem is for you to try. So hit pause on this video, give this problem a try, and I will come back and show you my answer. Okay. Interest. And then we want payoff. I equals P times R times C. And then capital T equals P plus I. So interest is equal to the principal, which is $5,000, times our interest rate as a decimal, which is 0.085, times the number of years, which is 6. So we have our numbers. Let's go get our calculator. And come on, there we go. 5,000 times 0.085 times 6 years. And that gives us, I just lost it, 2,550. $2,550. So there's the first one. And the payoff is principal plus interest. And that is $7,550. Okay. So that is our basic simple interest and how it works. Now from there, we can go into loans that are still simple interest loans, but they're not set up as 1-year loans. They're set up as partials. So it might be a number of months, or it could possibly be a number of days, just depending completely on how the loan is set up and the arrangement made between the borrower and the lender. Okay, there is no rule that says loans have to be yearly. No rules about that at all. So they can be any length of time you want. The idea is, or the way to correct our simple interest calculation here is to change it's called a change of base. So rather than working in years, we would have to adjust to either months or days. So if you're set up on this example here shows you 2 months or a 5-month loan. If you are given months, all you have to do is change that time amount. So right here, I'm looking at the 2, if it's a 2-month loan. So instead of putting T equals 2, because T equals 2 means years, right? Because everything was in years a few minutes ago. So we have to change this because it's not in years anymore. It needs to be in months. This means 2 months because 1 year is equal to 12 over 12 in months. Now, if we're given our amount of time in days, if we're told, we're going to have this loan for 90 days, then we could say that our time is 90. And then how many days are in a year? There are 365. And this would change our time to be in days as opposed to years. And so all we have to worry about is making sure that we change that bottom denominator there to fix it. And let's try that. So we have a little bit of a complicated scenario here. We're moving from, looks like Raleigh, North Carolina to Arizona. Yeah, so moving from Raleigh to Arizona. The company is going to pay us back for the move. So when we make this move, we're going to get our money back. We do the research and we determine that to move over there, just to move our stuff, it looks like. So the movers themselves are going to cost $5,600 to move our belongings. So I'm assuming that that probably means we're going to get some guys in a truck and they're going to carry it over there for us. So if I take out a simple interest loan for 45 days at 11.75%, what's that going to end up costing me in the long run? Okay, so what is my interest going to be? That's the first question we have to find out. So interest equals principal times rate times time. Okay, so we know that our principal is $5,600. And we know that our interest rate is 11.75%. So we always want to translate that into a proper decimal. And our time is 45 days. It's a 45-day loan. So it's 45 divided by 365. Okay, from this point, you're set up properly. Now all we need to do is do the calculations. And this is where this fancy little Desmos scientific calculator comes in handy, because it lets us be a little bit more fluid with our calculations. So we have $5,600 that we're borrowing, and we're going to multiply that by our interest rate. Everything's the same as what we've done so far. And here is where it's going to change a little bit, because the next thing I need to multiply by is a fraction. So use the fraction button over here on the right-hand side of the screen. I hope you can see my pointer. I'm trying to flash it and make it, flash the little thing in case you can't. But it's under the wrench and it says A over B. So use that and it will give you a fraction symbol in the line. So now all we need to do is the 45 on the top, move our cursor down to the denominator, and enter the number of days in a year in the denominator. This tells us $81.12, it looks like. So I equals $81.12 to borrow $5,600 for 45 days. Now, they don't specifically say, actually, they don't say anything in here about what they're looking for. This just tells us a story. So if this is the interest rate or the interest that I have to pay back for borrowing this money, what is my total payoff? I'm going to give you just a second to think about that while I write it. So to calculate our payoff, remember we say total equals principal plus interest. So my total is going to be my principal, $5,600, plus my interest, which is $81.12. So my total payoff is $5,681.12. Okay, nice. So let's go do another one. I think I'm going to let you try this one. Yeah, you try this one. Go ahead and hit pause and give this one a try. And then come back and see if our answers match. Don't forget to check out that Desmos Scientific Calculator while you're at it. Okay. So our interest, that's the first thing we want to figure out. And then we'll go ahead after that and do the payoff. So interest equals principal times rate times time. Our principal is $7,800. Our interest is 0.1075. Principal, interest, and our time is 85 days. Okay, looks like I have everything. So let's get our handy little calculator here. And we have our principal. Oops, I'm going to get into another box here. Our principal, $7,800, times our interest rate, which is 0.1075, not 65. Yep. And then we have our time, which is 85 days. So that's where we need to use the fraction. And that leaves us with an interest rate of $195. And notice that this is 0.267. So I'm going to go ahead and write all of that down. 195.267. Now we're dealing with dollars and cents still. So coins, cents, those are the hundreds place because there's 100 pennies in a dollar. So we need to focus our attention right here. So proper rounding would be to 2 decimal places. So we're going to say, look at the 7. 7 is larger than 4. Okay. So that's going to round up. So this is going to be $195.27 as our interest rate. Now our payoff, we have total equals principal plus interest, which is principal, $7,800, plus our interest rate of $195.27. means that we're going to need to pay back $7,000. Add those two together, $995.27. Okay, so that is doing simple interest where we have a completely different basis as far as time goes. So let's see what happens when we are still looking at simple interest, but now we want to know what future value we're going to have. So in this case, we want to start thinking about, okay, I'm taking this money, that's my money, and I'm depositing it into an account for a certain length of time at a certain simple interest amount. And what I want to know is how much money am I going to have when this time is up? I want to know ahead of time if this is a good place to put my money, or if maybe I want to take it to a different bank that's going to give me some different conditions. So when we want to know how much we're going to have at the end of the time period, that's called our future value. Future value, anytime we're doing an investment, we use the term future value. The future value is equal to the principal plus the interest. And I hope you're thinking, but wait a minute, you just told me that the payoff is the principal plus the interest. Because I did. That's what I said a second ago. Payoff is principal plus interest. Future value is principal plus interest. So the words that we use, payoff versus future value, depends on who we're talking about or what role we happen to be in at that moment. So if I'm looking at future value, then I'm the one investing. I'm the one doing the investing. If I'm talking payoff, then most likely I'm the borrower. Okay? Because I'm doing the calculations to determine what I am going to have to pay when that loan is up. So that would be the payoff terminology. The future value terminology is I want to know how much the bank or whoever is going to give me back when this is all done. Right? So our calculations here are going to be the same. We're just referring to, using different terminology, I think is the best way to put it, based on our point of view at the time. So let's just try one and see what happens. So determine how much interest is earned on the investment and the future value of the investment if the investment yields simple interest. Okay, so I love this question. If the investment yields simple interest, they will. So how much interest was earned? So that's going to be our interest formula. Because this is simple interest, I equals P times R times T. And then we want to know the future value. So future value is equal to the principal plus the interest. All right, so I equals PRT. Principal, 1,000. Interest rate as a decimal, and the length of time and the number of years. Okay, so I am not going to pull up Desmos for this one because we have done so many problems exactly like this. I'm just going to do this on my handheld. I'm saying 1,000 times 0.0201 times 5. And we have $100.50. Now to calculate my future value, what I need to do is take my principal, which is $1,000, add my interest, which is $100.50, and we have a future value of $1,100.50. Okay, now this next one, I think we can do pretty quickly, even quicker than the one just a moment ago. And then we'll let you try the third one. So hopefully, maybe you're even ahead on this one. So the same thing, determine the interest and the future value. So my interest is equal to principal times rate times time. So interest is equal to 3,000 times my rate as a decimal times the time, which is 3 years. Interest is equal to 3,000 times 0.0465 times 3, which is $418.50. So there's my interest. My future value of the investment is going to be 3,000 plus 418.50. So $3,418.50. All right, this next one, I would like for you to try that. So go ahead and hit pause. And when you come back, I will work the problem out and we'll see what you got. Okay. Interest. I equals P times R times T. My principal is 2,000. My interest rate is 0.0825. And I have no idea why I just wanted to add those two. And my time is 6 years. So we'll do those calculations. 2,000 times 0.0825 times 6 is $990. My future value is my principal plus interest. So my future value for this one is 2,000 plus 990, or $2,990. Okay. Last thing that we want to look at today, I believe. No, two more things. Two more things we want to look at today. The next one is actually computing a partial payment. So we have a simple interest loan, and those simple interest loans typically like to be paid off all at once. Okay, you one payment, one and done. You know, you go get your loan, and they say 6 months from now, this is how much money you're going to pay me back. But a partial payment is when, maybe you get halfway down the road and think, I would just really like to pay part of this so that I don't owe quite as much in one lump sum at the end. So we calculate partial payments because when we do that, we're always going to take some interest off. Some interest is going to come out of that payment. It's not all going to go to the principal. So calculating a partial payment, we're still going to use our simple interest formula. We're still going to use I equals P times R times T. But the way that we're going to do that is, I think that we are missing a slide. Okay, no, we're fine. We're fine. I got ahead of myself. So the first thing that we want to do is just exactly where we were going. We want to calculate the simple interest on this partial payment that's made, in this case, 85 days into the loan period. So how much of it would be interest? Okay. So interest equals, we have our principal of $8,500 times our rate of 0.104, because it's 10.4%. And then we are 85 days in. So remember, when we are dealing with days, we have to change this. Put that over 365. We can't just use the time 85. We'll get a really, really ugly number. So 8,500 times 0.104 times, and I'm using a TI-84, so I'm opening a parentheses here, saying 85 divided by 365, and then enter. And we have our simple interest of $205.86. So however much of a partial payment you decide to give at this 85-day point, $200 of that payment is going to be interest. Okay. So this next topic is where I thought I was just a second ago, thinking I was doing it completely wrong. When we're thinking about repeated partial payments. So these repeated partial payments are where we're doing something like a car loan or a mortgage or anything that we make regular scheduled payments. Typically, these payments are per month. There are cases where you'll see something different, but typically, most of us are only going to deal with monthly payments. Okay. So loans for cars, generally speaking, again, very broad, generally speaking, 3 to 6 years. Mortgages, 15 to 30. If we were to go through there and do every single payment, just like we did with that simple interest a second ago, that would get kind of frustrating. It would be very time consuming. You would be just doing one calculation right after the other. You think about it, 3 years doing one calculation every month to figure this out for the next 3 years, that is 36 times. And that's only on one loan. So we don't want to do that. That's just entirely too much. So we have another formula. We've got a new one here, and it's a pretty big one, a little bit on the scary side, but we will walk through this and we'll use that Desmos calculator to do this one. So amount of the monthly payments is A. A over here, that's how much your payment will be. Principal is still P. Monthly simple interest rate in decimal form. Please notice that this says monthly simple interest rate. So that means that we have to take this R and divide it by 12. So this should really be over 12. T is our number of months. So even if they give us 3 years, it's going to be time in months, not time in years. It's found with this formula. The monthly interest rate is the annual rate divided by 12. The number of months is the number of years times 12. Okay, so let's just jump in here and calculate this car. So Desiree buys a new car by taking a loan out from her credit union. The balance of her loan is $27,845. The annual interest rate Desiree will pay is 7.3%. She plans to pay this off over 4 years. How much is the monthly payment going to be? Okay, step 1. We need a formula for that. We're looking for the amount of our monthly payment. So it's A equals principal times, and I'm putting a big old parenthesis here, R, which is my rate per month, times 1 plus R. Now this 1 plus R is raised to the T power all over 1 plus R raised to the T power minus 1. Okay, big, messy, scary formula. But we're going to figure out what each letter is, and we're going to fill in the blanks. So the first thing I'm going to do is come over here to the left side, and I'm going to say P equals what? R equals what? And T equals what? So my principal is $27,845. My interest rate is 7.3%. That's my annual. I need this to be in months for this equation. So the first thing that I'm going to do is change this to a decimal. And then remember that we need to divide by 12. And I'll show you an easy way to put that into the calculator in just a second. Finally, T is my time, and that is 4 years. But recall that we want this to be in months. So we need 4 times 12. Okay. I'm going to fill in this equation over here first, and then we'll go to our Desmos calculator. So A equals 27,845 times my rate is 0.073 divided by 12. And I'm going to use the fraction bar for that. That's multiplied times, put the big one in here too, 1 plus R again, 0.073 divided by 12, raised to, so we close that. T is 4 times 12. And that is all over 1 plus the rate raised to the T times 12 minus 1. Okay, that looks big and scary. So let's go get our scientific calculator over here and plug everything in. All right, so we have a few things going on. The first one is our principles, 27,845. I'm going to open a parenthesis here, and then I'm going to get a fraction. All right, so at this point, I'm on the top in the numerator. So my cursor is up here. Oh, excuse me. I did not mean for that to disappear. So now I need another fraction because I have to have one for the interest rate there. So I'm going to click A over, I'm going to make sure I'm in the numerator first. Then I will click A over B up here. Press it again. That puts me in the numerator. I have 0.073 over 12. All right, that's my first rate. So I'm going to open another parenthesis, 1 plus, and I need another fraction. So fraction, 0.073 over 12. And we close this. Now notice that we have this 4 times 12 up there. So I'm going to press AB, and it's going to take my cursor up into the exponent location. And here I have 4 times 12. Oops. You see how that went down? We don't want that. So we're going to, not there, we want there beside 12. Backspace all of that. Come up here again. He does not want to cooperate. Times. No, he doesn't. So if he doesn't want to cooperate, we'll put in parentheses, 4 times 12. Okay. That's the top. Now let's go to the bottom. So denominator, make sure your cursor is down there. Open a parenthesis, 1 plus. Now we need a fraction. Rate divided by time, which is 12 months in a year, because we need a monthly rate. Exponent, I'm going to put a parenthesis there because we know they don't like it if it's not. So there's my 4 times 12 for my time is 4 years. I'm going to get out of the exponent by pressing the right arrow. Then we need -1. And last but not least, I need to come out here and make that fraction go away. And we have our car payment of $670. And I forgot what the change was. It looks like 67 cents because we need to round that to the coins. So $670.67. Okay. A lot going on in that problem. A whole lot going on in that problem. Please reach out to your instructor, whoever they might be, if you are having trouble with that problem. Present value is our next challenge. So present value is all about, I know that at the end of a certain amount of time, I want to have so much money in the bank. And I also know that the bank is going to give me a particular interest rate. So how much do I need to put in today or next week to have X amount of dollars in the bank in however many years? That's the short version of present value. Present value is basically figuring out what you have to do today to have a certain amount so many years in the future. So we need to compute the present value of the investment described and interpret the results. So my future value is 10,000 and it's 15 years and my annual simple interest rate is 5.5%. So first thing we need is our present value formula. And that is PV equals, for present value, future value divided by 1 plus the rate times the time. My future value, I'm not going to relabel because it's pretty clear in our question. So present value equals future value is 10,000 divided by 1 plus the annual simple interest rate is 5.5%. So as a decimal, 0.055. No, that was right. Times the time, which is 15. So present value equals, and I'm going to go back to Desmos for this one because of the fraction and complicated denominator. So we have a fraction. $10,000 is in the numerator. And in the denominator, we have 1 plus, I'm going to open a parenthesis just to be careful, 0.055 times 15 years. And enter. And it looks like my present value is $5,479.45. 547945. 547945. Okay, trick with present value. When we are calculating present value, we always want to round up to the next dollar. So we are going to give this present value as 5,480. Yes, for those of you that are thinking it, you are correct. That is not proper rounding. Always round up. Always round up. The last thing that we need to do is interpret these results. So if I was to write this as a statement, we would say to have, and this is not perfect, to have $10,000 in 15 years given 5.5% annual simple interest we should deposit 5,480. Okay. So that is not the only way to say that statement. There are many other ways that you could word it and say exactly the same thing, but the idea is to mention that you need to deposit 5,480. You're going to have 10,000 in 15 years, and your annual simple interest rate is 5.5%. So say those things however you would like to say them, but get all that in there. Okay. So I'm going to do faster. and then we will let you do one problem, and we will call it a topic. So, compute our present value if we want to have $12,000 in the bank in 10 years, given we have a simple interest rate of 6.25%. So, present value equals future value divided by 1 plus the rate times the time. Okay, so our future value is 12,000. We're going to divide that by 1 plus our rate, which is 0.0625, times the time, which is 10 years. Okay. So let's go get our handy little Desmos Scientific here. Come on. There we go. And we have a fraction. In our numerator, we have $12,000. In the denominator, we have 1 plus, open parenthesis, our interest rate, 0.0625, times the number of years we're going to leave the investment in the bank. So our present value, what we would need to deposit, $7,384.62. $7,384.62. 38462. Please do not forget to round up to the next dollar. Okay, so 7,385. All right, last example. I'll give you a second to do this one, and then we will come back and compare notes. Okay, present value, once again, is equal to the future value over 1 plus the rate times the time. So for this problem, present value is equal to a future value of 8,000 and a rate of 0.0475, and the time is 7 years. So present value is, and we're going to do our Desmos Scientific again one last time today. And we have our fraction. We're dealing with $8,000. 1 plus our rate, 0.0475, times our time of 7 years. Close that one. $6,003.75. $6,003.75, which always rounds up. So 6,004. Okay, so I hope you enjoyed this section a little bit at least, and got something out of it. If you have any questions or concerns, please reach out to your instructor. That's what we're here for. We love to answer your questions. So just let us know what you need, and I hope you have a fantastic rest of your day. Thanks so much for joining, and we'll talk to you next time.